Hi everyone, this is Dr. Nak and we're going to go over section 7.5. A title is Unit Circle and Properties of the Trig Functions. So unit circle is a circle whose radius is 1. And I've already drawn you a picture there to save some time. So let t greater or equal to 0 be any real number. And s is the distance from origin to t. So basically this guy is s. Alright, so now wrap the red line of the length t onto the circle. Then the arc length from 1, 0 to p is t. So basically you're going to take that, pretend that red line is a string, and you're going to place it on the circumference of the circle. And the end point of that string, we're going to denote it by p, which is an ordered pair, a comma b. Alright, and it says a comma b is called a point p on the unit circle that corresponds to t. Okay, so let's go with the definition. Let t be a real number. P equals a comma b, a point on the unit circle that corresponds to t. Then sine of t is b, cosine t is a, tan of t is b over a, and so forth. You see it right there. Okay, so do you remember sine of t was what? Sine of theta was b over r. And cosine of theta was a over r. So it's basically the same thing, but notice that our radius is 1. That's why this is going to become just b, not b over r. Okay, let's do an example. Let p be the point on the unit circle that corresponds to t. Find all 6 trig values. Okay, so let's try to understand this by drawing the picture. Boom! That's not a cool feature. Okay, so let me just do it like this. Oh, that's so pretty. All right, anyways, so this point is 1, 0 because we're talking about the unit circle. All right, so now let's plot our point P, which is x is negative root 3 over 2 and y is negative 1/2. So I'm just gonna pick a point here. So let's pretend that this is negative square root of 3 over 2. And this point right here is negative 1/2. All right, so this point P, I don't know if you can see this point. Let me just draw it in blue. All right, so this P is negative square root of 3 over 2, comma negative 1/2. Okay, so by the way, so this is going to be our A, this is going to be our B, and the arc length that we're talking about is, let me just hope you can see this portion. So basically we're taking that red string and wrapping it around alongside of the circle to get to our point P. Okay, so then what's gonna happen is what? So we're gonna have to find sine of t. Oh, so what is t, right? So this whole length right here is your t, by the way, where I shaded in blue. All right, but sine of t is nothing but b over r, but r is 1. So b is negative 1/2. And cosine, cosine of t is a over r, but a is, r is 1. So this is nothing but negative root 3 over 2. Okay, so we got sine and cosine. Great, we should be able to derive the other stuff without memorizing anything. So tan of t is what? Sine over cosine, so which is b over a. And 1 over square root of 3, rationalize, you should get root 3 over 3. And then cotangent of t is just 1 over the tangent. So 1 over the tangent is going to be just square root of 3 over 1. So it's just square root of 3. Now secant of t is 1 over the cosine. So in this case, we're going to get negative 2 over root 3 Rationalize that to get negative 2 root 3 over 3. And lastly, cosecant of t is nothing but 1 over sine, so our answer is going to be negative 2. So this is what the question's asking you to find. Okay, so the next topic is trig function of angles. So basically I'm drawing the same picture as before. Now the only difference is that I'm going to introduce a theta from the initial side to the terminal side, as we always do. And point P is the terminal side of the angle theta in radians. Okay, so in that case, sine of theta is going to be sine of t, cosine theta is cosine t, and so forth. Okay, so let's just go over the theorem. For an angle theta in standard position, P equals A comma B be any point on the terminal side of theta that's also on the circle, x squared plus y squared equals r squared. This is just an equation of the circle was centered at 0, 0 with the radius r. Then sine of theta equals b over r, cosine theta a over r, and so forth. I think we've seen this before in section 7.4, pretty much the same thing. Alright, so let's look at some examples again. So example 2, find the exact value of 6 trig function of an angle theta if 2, negative 4 is a point on its terminal side. Okay, so again, let me just draw some pictures here just to understand what's going on. Now I'm going to plot 2, negative 4. So let's make this maybe, this is so hard to draw. Let me see. Maybe over here is 2, and here's negative 4. Okay, and then our initial side is of course positive x-axis always. And then our terminal side is going to be over here. And our angle theta that we're talking about is always from the initial position to its terminal side. Okay, so first what we need to do is what? We need to determine what the radius of the circle is. So let's just use the formula x squared plus y squared equals to r squared to solve for the radius. So again, this is your x, or a, same thing as a, and then this is going to be y value, which is equivalent to b. So keep that in mind. All right, so our r is going to be what? Square root of x squared plus y squared. So here you're going to have 2 squared plus negative 4 squared. So here you're going to have square root of 20, which is 2 square root of 5. Okay, so that's going to be our radius. So let me write that out. So this here is 2 root 5. So this right here is 2 root 5. And this is negative 2 root 5, and then negative 2 root 5. Okay, so what do we got going on here? So we have a equals to 2, which is same value as x. B equals to negative 4, and then our r is 2 square root of 5. Okay, so with that said, we should be able to derive this, so let's go. So this means what then? Sine of theta is b over r, which is negative 4 over 2 root 5. Rationalize, then we're gonna have what? Negative 4 root 5 over 10. Always reduce, so this is what? 2 goes into 4 and a 10, so we get negative 2 root 5 over 5. Okay, so that's the sine of theta value. All right, now let's go with the cosine. Cosine of theta is a over r, which is 2 over 2 square root of 5, so which is 1 over root 5. Rationalize to get root 5 over 5. Okay, we got the sine and cosine. We're all good to go. Okay, so the tangent of theta is sine over cosine, so it's going to be b over a. So you're going to have negative 4 over 2, which is negative 2. All right, and then cotangent of theta is opposite, not opposite, reciprocal of tangent. So here you're going to have negative 1/2. And then what do we get? Secant. Secant of theta is 1 over cosine. So you're going to have, where's my cosine? So here you're going to have just square root of 5. And then cosecant of theta is just 1 over sine. So here you're going to have negative 2 root 5 over negative, over 4. Same thing as 2 root 5 over negative 4. So which is going to be what? 2 goes in. So negative square root of 5, that's a 5, sorry, over 2. And that's what the question's asking you to find. Okay, next topic is domain and range of the trig functions. And domain is settable x values where the function is defined, and range is of course settable the y values where the function is defined. Okay, so don't freak out about the notations. So let's first go with the sign. The symbol is f. F of theta equals sine of theta. Instead of f of x equals sine of x, the variable is just became theta, and that's all. All right, but anyways, domain is settable x values such that x is all real number. Okay, so the little curly bracket in the math class means settable, and then you see the x, right? X, and the bar means such that x is all real numbers. And for the sine and cosine, domain and range are the same. So cosine and sine, the domain is all real numbers, and the range, all the y values are sandwiched between negative 1 and 1. All right, now for the tangent, the domain is settable x such that x cannot be the multiples of pi over 2. Okay, and then for the range is all real numbers. Okay, so for the cotangent, the domain is settable x such that x cannot be a multiples of pi. All right, and then y is, the range, I should say, is all real numbers. And secant is, the domain for the secant is settable x such that x cannot be a multiples of pi over 2. And, oh, my dog agrees. All right, and then the range is settable y such that y is greater or equal to 1 or y is less than or equal to negative 1. And for the cosecant, domain is settable x such that x cannot be a multiple of pi, and the range is settable y such that y is greater or equal to 1 or y is less than or equal to 1. And just in case you forget what the notation means, I just wrote it down there in green. Thank you, Kasha. She's learning the notation as well. Okay, next definition is a function f is called periodic if there is a positive number p such that f of theta plus p equals f of theta. If there is the smallest such number p, p is called the fundamental period of f, but we just call it period of f. So I've already drawn you a picture there with the unit circle. Now the terminal side is determined by revolving around pi over 3, which is 60 degrees. Now if I plot the point along the side of a unit circle, that point can be represented by 1/2 comma root 3 over 2. And if you recall that sine of pi over 3 is root 3 over 2, now look at the point, and then if I revolve around the circle 360 degrees or 2 pi, do you see that? We're going to get to the same exact terminal point. And then if I add 4 pi from the starting point, you're also going to get back to the same terminal point. Okay, but the p is the smallest value, so p in this case will be 2 pi, because if I add 2 pi to any point along the line of the circle, you're going to get back to the same terminal point. So therefore, sine of pi over 3 equals sine of pi over 3 plus 2 pi. And we say that the period of sine is 2 pi. Okay, so I've already wrote down the periodic properties. So notice that sine, cosine, cosecant, and secant, their period is 2 pi. And for the tangent and cotangent, the period is pi. All right, so let's look at the next example. Find the exact value without using the calculator of cosine of 420 degrees. Okay, so I've already written out the problem here, so let's just go over this. So cosine of 420 degrees equals cosine of what plus 360. Okay, so that what question part will be 60 degrees. So cosine of 420 degrees should equal to the cosine of 60 degrees, which means that if you plot a point on the circle where the 420 degrees ends, that point is same thing as 60 degrees from the initial side. So it's basically the same thing as reference angle. Okay, so anyways, so therefore cosine of 420 is cosine of 60, which is going to be 1/2. Okay, so let's look at the next example. Tangent of 21 pi. So I just purposely wrote down some huge number. But notice that the period of tangent is pi. So the question is, oops, why is that in red? Sorry about that. How can I rewrite this as tangent of what plus pi is going to give me the tangent of 21 pi? Well, that question mark should be 20 pi, because 20 pi plus 1 pi will give us 21 pi. So let me write that out. So this is tangent of 20 pi plus pi. Now again, notice that pi is the period of tangent. All right, and so according to the theorem, this is going to be the same thing as tangent of 20 pi. Crap, this is a pretty big number. Now let me just draw the circle here. Okay, so here's my initial side. Now if you don't like the radian measure, do 20 times pi, which is pi is 180 degrees. So if I multiply 20 times 180, what is that? 3600. And then if you divide that by 360, that should tell you how many times you're going to have to revolve around that circle. So let me just write that out instead of me mumbling. So notice that 20 pi, I'm just going to write it over here. 20 pi is same thing as 20 times 180 degrees, which is what, 3600 degrees. Now if I divide this by 360, you're gonna get 10. Alright, so that means that you're gonna have to revolve around the circle starting from the initial point 10 times. So you're gonna go 1, 2, 3, 4, I don't want to keep doing it, but you know what I mean. So after you revolve around 10 times, you should end up here, which will be what? 1, 0. All right, so this is going to be the value of A. This is going to be the value of B. All right, so with that said, this is going to be tangent of 20 pi is going to give us the same value as tangent of 0, because the angle at that point is just 0 degrees or 0 radian. Okay, so then tangent was what? B over A. In this case, you're going to have what? 0 over 1. So therefore, 0. The answer is going to be 0. So therefore, tangent of 21 pi equals to 0. Okay, so the next definition is even and odd function. Might want to memorize this one. So the function f is an even function if f of negative theta equals f of theta, and f is odd if f of negative theta equals negative f of theta. Okay, and let's look at the theorem, even and odd properties. Okay, so sine of negative theta equals negative sine of theta. I don't think I should be reading this because I already wrote it out. So basically, sine is an odd function and cosine is an even function. Okay, so that means what then? Tangent has to be odd, because tangent is sine over cosine, and sine being odd function, then tangent is going to be odd. Now the cosecant is also an odd function because cosecant is 1 over sine, and sine is an odd function. And secant is an even function because secant is what? 1 over cosine, and cosine is even. So therefore secant is even. Now cotangent should be odd because we already determined that tangent is odd, and cotangent is nothing but 1 over tangent. So the cotangent is also an odd function. Okay, example time. All right, so example 4, use the even odd properties to find the exact values. So let's do a couple of examples. So let's look at sine of negative 135 degrees. Okay, so since sine is an odd function, first step that's going to happen is this. Pull out that negative. So sine of negative 135 is same thing as negative sine of positive 135 degrees. Okay, so now let's just see where that 135 is going to lie in. All right, so 135 degrees should lie in where? Quadrant 2. So this is 135 degrees. Then its reference angle should be what? 45 degrees. Oh, sorry about that. So this is my initial side, and right here is going to be our terminal side. Okay, now let's do the positive quadrant business. All students take calculus, and since the angle lies in quadrant 2, I'll just write everything out. So sine is going to be positive in there. So this sine of 135 degrees is same thing as, by using the reference angle theorem, negative sine of 45 degrees. Okay, so if you have memorized it, this is what? Negative sine of 45 degrees is root 2 over 2. So the answer is going to be negative root 2 over 2. Oh, I just noticed that it's all student take calculus, so this should be C there. Sorry about that. Okay, so let's do another one. So let's go with B. How about secant of, let's do some quadrantal angles, negative pi. Okay, so is secant even or odd? Well, secant is 1 over cosine, right? And cosine's even, therefore secant is an even function. So this is going to give us the same value as secant of pi. In case, I know I talk really fast sometimes. So from here to here is because secant of theta is an even function. And sorry, I'll just go back to part A. From here to here is because sine of theta is an odd function. All right. So now let's find out what the secant of pi is. Well, secant of pi is same thing as 1 over the cosine of pi. So let's figure it out what the cosine of pi value is going to be. So I'm going to draw our unit circle for the quadrantal angles. Okay, so this is what? 1, 0. This is negative 1, 0. Okay, so that's our A. That's our B, and here's my initial side, and our terminal side is going to be right here because we're revolving around 180 degrees. So this is theta equals to pi. Okay, so I think we're good to go. So this is going to be what? 1 over, now cosine of pi, remember cosine was what? A over R? A over R, so I'm just going to write that out. So which is what? 1 over A is negative 1. Since we're talking about the unit circle, R is 1. So therefore, our answer is going to be negative 1. Oh, what the heck. Let's do another one. So let's call this one C. All right, so what can we do? So let's try something like tangent of negative 6 pi and plus cosine of 9 pi over 4. Okay, so let's take one thing at a time. So this is same thing as what? Tangent is an odd function. So let me change the colors around. Oops. So this portion is now becomes negative tangent of 6 pi because tangent is odd. Where can I write that? Okay, and then plus cosine of 9 pi over 4 doesn't change, so let me just keep it as just cosine of 9 pi over 4. Okay, so let's compute this separately. So let me just compute this one. So let's work this tangent of 6 pi, what the value is going to be on as a side work. So I'm just going to bring it over here. Okay, so let me just draw the picture and see what's going to happen here. All right, so we're given the quadrantal angles again. So I'm going to call this point 1, 0, negative 1, 0. All right, so we're going to have to revolve 6 pi. So let me just, so this is going to be our initial side. All right, so if I revolve, what is it, 6 pi, so you're going to have to go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and then 6 pi. Okay, so it looks like we're going to land at the 0 degrees right there. Okay, so keep that in mind. And then, so tangent was what? Negative b over a, because it's sine over cosine. So your tangent portion is going to become negative 0 over 1. All right, which is going to be 0. And then let me just work as plus and a plus. Let's work cosine of 9 pi over 4 as a side work. So I'm going to take this one down here. I'm going to do the same business. Let's just draw it out. Oh my gosh. All right. So by the reference angle theorem, cosine of 9 pi over 4 is just going to be cosine of pi over 4. So this is just going to become cosine of pi over 4. If you don't believe it, just, you could just go around the circle to find the coterminal point if you like. All right, but anyways, 45, pi over 4 is 45 degrees. So here's the initial side. All right, we're going to be revolving around this, but we're going to end up here. All right, so this is going to be the terminal side. This is so ugly, sorry. All right, I hope you can see this part. So the reference angle here is nothing but pi over 4. Okay, so what's cosine of pi over 4? It's root 2 over 2. So let's put it all together then. So negative 0 over 1 is 0 plus root 2 over 2. So our answer is going to be root 2 over 2. Okay, so let's just do another one. What the heck? Practice, practice, practice. All right, so let's take a look at something a little bit uglier looking. Cosine of negative 17 pi over 4. And then minus sine of, oh, what the heck, minus 3 pi over 2. All right, so let's take this one step at a time. Now, since cosine is an even function, cosine of negative 17 pi over 4 is just gonna become cosine of 17 pi over 4. And then minus, sine is an odd function. This minus is this minus, by the way. All right, sine's an odd function, so here it's gonna become negative sine of 3 pi over 2. So from here to here, we just use even and odd properties to get here. And just clean up a little bit. So this is what? Cosine of 17 pi over 4. And then plus sine of 3 pi over 2. Okay, so let's take a look at this one. Now, you don't have to do it this way if you don't want to, but notice that 17 pi over 4 is going to be more than 2 pi. Okay, so in that case, you can use the periodic property for the cosine if you want to. Or you can just skip this step and you just can go around and around the circle to get to the terminal point. But let me just show you how to do it in a little bit different way. So you know that the cosine has period of 2 pi, right? So then let's just call this guy question mark. Okay, so let me just write this part out before I forget. So cosine of what plus 2 pi is going to give us 17 pi over 4. So how do you find that as what then? So 17 pi over 4. Let me just change the color. 17 pi over 4 equals what plus 2 pi. So how do you find the what? What is what? 17 pi over 4 minus the 2 pi, but 2 pi is what? 8 pi over 4. So the value is going to be 9 pi over 4. Okay, so basically you can rewrite this as, let me see, 9 pi over 4 plus 2 pi. So according to the periodic property, this is going to give us the same thing as 9 pi over 4 and then plus sine of 3 pi over 2. Alright, but the cosine of 9 pi over 4, its reference angle is pi over 4. So again, you could completely skip that step if you wanted to, but I just wanted to show you some different ways to do it. But anyways, so let me just draw the circle. Alright, so here's my initial side. And if I revolve 9 pi over 4, your terminal point should be here, and our reference angle is going to be pi over 4. Okay, so let me just write down, this is theta equals to 9 pi over 4. Alright, so this is going to be cosine of pi over 4, and then plus sine of 3 pi over 2. Alright, so let's work on sine of 3 pi over 2, which is 270 degrees. So let me take this guy down here and just work it on this as a side work. Oh my gosh. Oh, that's supposed to be a circle. Alright, so anyways, this is 1, 0, 0, 1, negative 1, 0, and then this is what? 0, negative 1. Okay, so here's our initial side, and 3 pi over 2, our terminal side is going to be right here. So this is 3 pi over 2. Okay, so remember that sine is b over r. So again, I don't know if you can see this. So this is the point that we're talking about. So this is your a and this is your b. And sine of 3 pi over 2 is what? B over r. Since we're talking about the unit circle, radius is 1, so you're going to have negative 1 over 1. So it's going to be negative 1. Okay, and so let's put it all together. Cosine of pi over 4 is root 2 over 2. And then minus 1, because sine of 3 pi over 2 is negative 1. Alright, so put them all together. What do we get? Root 2 over 2 minus 2 over 2. So root 2 minus 2, whole thing dividing by 2. And that's going to be the answer. Okay, so if you have any questions, please let me know.